Welcome. Today we're going to talk about micro-segmentation in the cloud and how that's possible. My name is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers. I'm joined by Bryan Ashley, who's a VP of Marketing over at Aviatrix, Woody Woodworth, who's a Director of Solution Strategy at Aviatrix, and Mark Miloknovich, who's actually our Chief Technology Officer. Now, this is a really exciting topic for me, and it's an exciting topic because security is top of mind for me as an architect, and it's top of mind for everyone. And when we go to the cloud, and the cloud is wonderful, we lose so many of the security features we have in the data center. And without them, it's kind of scary. See, in the data center, we could divide up our users into something called VLANs and keep them separated and then route between them. We can actually make two servers in the same VLAN, not even be able to talk to each other with a private VLAN. We can lock our systems down that if you plug a PC or a server into the wrong port, the switch will shut itself down. And we can even massage and rate limit the traffic so that if our data systems get a worm, for example, we can deprioritize that traffic to make sure critical traffic gets through. But in the cloud, we don't have any of those options. It's pretty much a shared network. The cloud provider has to allow everything through, because if they didn't, they'd have to know each person's traffic, and that wouldn't work. And we have no control over their systems. And this is a real scary thing from a security perspective. So on the cloud, we get creative. We may have to divide our organization into 1,000 virtual private clouds. We may have to do some fancy routing between them. And for people like me and Mark that like to get geeky in routing, it's not a big deal. But for the rest of the people out there that don't live, eat, and breathe and sleep networking, or people that didn't work for Cisco for the better part of their lives as a network architect, these are serious challenges, and I'm excited to have Aviatrix here. So I'll start with Aviatrix. Maybe you can describe some of the differences between traditional networking and cloud networking.
Sure, I'll take a stab at it. So most cloud networks, if not all cloud networks, are layer 3 switches. So what does that mean? That means that the atomic particle of the communication between any two entities or endpoints is going to be routed, not switched. That means when you put two endpoints together in the same subnet, although they could physically be very far apart, even in different data centers, or for example, with GCP in different regions, that they are not going to have any layer 2 affinity whatsoever. So it is very difficult for networking and security professionals to design with that kind of what feels like a limitation. In some ways, it can be liberating, but in other ways, it can be severely limiting, to your point, because your options for shunting traffic and isolating traffic all have to be done in one of two ways. They have to be done by suppressing routing, which could work, but then you get no information between those two endpoints. You don't know if there's threats that are attempting to transpire between them. You lose all visibility, right? The other way is to shove it all through some kind of ACL or firewall that sees them, but now they necessarily connect and route. And thus is the conundrum of microsegmentation in the cloud.
And they're big weaknesses. I mean, they really are.
Yeah.
And they're real challenges too. If they're not in the same subnet, how is ARP going to work, for example? And how do you rate limit it? How do you do it? And yeah, that's typically what I would think of. Divide into 1,000 VPCs. Be very careful with your routing information into who can receive what. But then that's going to make a whole new set of complexities and challenges, especially when it comes to failovers and things like that. So yes, I agree. So if we don't want to create 1,000 VPCs and route in between them with BGP and stick virtual routers inside of the cloud and create all these routing policies, I know you guys have got a lot of good options here. How does your solution work to simplify the means to micro-segment the systems and get the information back and forth without hiring a team of network architects from Cisco and Juniper Networks?
Yeah, in my mind, that's such a great question. I think, one of the things that is super interesting about, organizations who go to the cloud is they have this tendency to leverage a lot of what cloud gives them. And so there are some native constructs where the cloud providers try to help you here, right? They will have network security groups and security groups that allow you to get very, very granular in how you can provide sort of stateful or stateless ACLs to control traffic. Now, the other part that where this gets really, really interesting is even assuming that you can solve all of these problems, and assuming you either have the really smart routing folks on staff to be able to do it from a routing perspective, or you leverage the native constructs. In the on-prem world, we didn't have someone going into a data center and moving a piece of compute from one rack to another or from one data center to another. But in clouds, that happens quite a bit. And we also now have workloads like Kubernetes, which are spawning things left and right in different pods, which just completely blow our security policies out of the water. Yeah. So on top of just finding a way to enforce this stuff, you now have to worry about the dynamic environments of everything changing, resources spinning up and down. The idea of IP addresses as sort of your identity gets a little flaky in certain dynamic environments. So our approach has been very much cloud-centric. How do we look at doing some of these things in a distributed way that can also handle dynamic behaviors while keeping centralized governance and policy control, right? At the end of the day, when we look at really what the outcome of security is they want a central pane of glass to be able to establish a policy set and a way to ensure that the things that it's governing are actually being governed, a way to audit that in some meaningful way. And so what we have tried to do from an Aviatrix perspective is simplify some of the native routing constructs to where we can give folks the traditional mechanisms to be able to enforce some of these controls. This would be, for all of my lovely networking geeks out there who I commiserate with, things like VRF control in simplified ways to be able to provide isolation where environments are ships in the night. We provide simplified ways for security folks to bring their familiar on-prem next-gen firewalls. And we could seamlessly insert those and control the routing so that we can ensure that environments are successfully routed through inspection points. Something that we announced last year was something called our distributed cloud firewall, which we effectively pushed this out in a distributed way. So all of the elements in your data plane start to become points of inspection and enforcement. Through that, we have also been able to leverage the native constructs as well for identification. This also allows us to facilitate sort of the dynamic nature of cloud. So we call these smart groups. You can think of them as objects inside of your traditional firewalls. But we're able to pick up on, of course, IP addresses, but things like CSP tags to use those elements as identifiers for policy enforcement. So what we try to do from an Aviatrix perspective is really layer on multiple ways of solving some of these problems, be it from a networking perspective or a cloud-based perspective, being able to handle the dynamic nature using cloud-native constructs like NSGs, security groups, or even cloud tags to do enforcement of policy in a distributed way, but still provide centralized control and governance.
And with some of these, next generation firewalls that you provide access for, do you make it that we don't need to start setting up GRE tunnels and removing some of that complexity as well?
We do. Yeah. If you ever tried to, we used to joke all the time, a couple of years ago, you'd try to launch a Palo Alto in the cloud and you'd have to download the 78-page administrative guide on how to do those things and figure out how to plumb it together. So yes, we have the API integrations into a lot of your common third-party next-gen firewalls, and we can stitch those in together, handle all of the routing, as well as provide active firewalling capabilities across multiple sets of firewalls, allowing you to not have to worry about any performance considerations. So we were able to, from a load balancing perspective, eliminate things like source NAT, which was typically a problem, to ensure symmetric traffic through inspection points. So again, just sort of another example of fundamentally understanding the limitations that the layer 3 networks that Woody described, which our cloud imposes on some of these stateful inspections, and be able to work around those through overlay technologies.
That's
You
really great.
mentioned that you have a dynamic approach to microsegmentation, and then with the onset of the distributed firewall that you released last year, could you go a little bit more in detail if this distributed firewall, as a workload migrates from one cloud service provider to another one, if it goes along with the workload, thus keeping that microsegmentation in place while still allowing us a way to take a look at the data as it flows through and from this workload?
Oh, great question. So the Aviatrix platform has a couple of key components. One key component is the brain of the platform, which we call affectionately the controller. For those that are into modern system design, that is your control plane, right? The controller speaks cloud native APIs for all the major clouds. So it's constantly aware of all of the objects that you onboard into it. You know, you give it a special set of account credentials or subscription credentials, and you bind it to the environments that you want it to shepherd. And then it will automatically see all of the networking and security objects in a cloud native way that you care about. And it will also read and perceive the tags on them. Then we provide an orchestration policy control method called, as Bryan said, a smart group, which is arbitrary and can contain arbitrary things, but usually contains VPCs, VNets, subnets, VNets, these kinds of things. And we allow you to organize them in meaningful structures for the purpose of governance and policy control. Such that when, say, a virtual machine moves from one cloud to another, one VPC to another, one region to another, as long as it still carries that same set of tags, the policy against it will be absolute because the controller sees that movement within seconds and knows to apply the policy in the network just where it matters. So that's another cool advantage of being distributed. You don't have to take all of your policy soup to nuts for everything in your cloud and shove it into one firewall instance or one DMZ deployment. Our system is smart enough to deploy the policy only where it needs to be enforced. Thus, the overall system performance and efficiency rises.
Now, correct me if I'm wrong on this particular understanding, but it almost sounds like you guys have found a way how to build the zero trust framework into the actual data plane, so to speak. Is that correct in my understanding?
Yeah, it gets pretty interesting, right? We start to get into a definitional problem of what is zero trust networking, right?
Mm-hmm.
Identity, especially when we come to workloads and applications, is interesting. Especially even more interesting when we get into Kubernetes and pods become very dynamic. Even more interesting when we get into things like serverless, right? Where we may not have any IP associated with it at all. So what this allows us to do, again, trying to understand the environment that we live in, which is cloud, and we have a mix of workloads and a mix of clouds with different rule sets and different identifiers. How do we start to provide, through sort of an overlay perspective, a way to uniformly do this and account for all the different variances? Not in a way that is requires the new CCIE of cloud, but in the way that is consumable to the average enterprise users. So it's been a really great journey. Actually, we've had customers help us shape the delivery of this, so that we have provided something that feels familiar to your traditional security folks and is empowered with some of the traditional functionality, but allows the sort of nuance of the individual cloud or multi-clouds to be solved for.
Fantastic. Thank you for the clarification.
Mm-hmm.
Oh, great questions. Keep them coming. It's fun.
Yeah, so I mean, I kind of like that it gives us the tools to go back and do the things that we've always needed to do that we were kind of limited on doing. And when I look at just some of the cloud native ways to do it, it always feels like we're lost. It always feels like I just need to do this, but I can't. And if I want to do this, I got to do these 15 workarounds to just get there. So having something that's simple that doesn't require me to do that, to me, really means a lot. So I think this is a fantastic solution to get around some of the weaknesses in the cloud. Is there, Mark, do you have any other tech questions?
Not on this particular subject, but I do want to say is that it's from an architect perspective, especially if I have to deal with clients, it's exciting to know that there is something as close as possible to a key turn solution out there where I can take something as pervasive as security and have it so integrated into my networking stack. So to be able to have that be able to carry the policies across, that to me is almost a 10 out of 10, so to say, especially if I have to try to solve problems for a customer and give them a solution that is not going to be overly complex. And as you guys already mentioned, because of the skill gap really that is there as we go from cloud, from traditional networking, and then we throw the whole software defined aspect of it in, I think that's where, to me personally, it sounds like this solution is quite well thought out of, to say the least.
Well, the revelation Bryan and I had, we worked for a major cloud provider. In this case, it was Azure for many years. So we've talked to hundreds and hundreds of enterprise customers struggling with zero trust and microsegmentation in the cloud. And one of the first struggle points was, okay, you have network security groups, but they're very difficult to orchestrate at scale and to manage at scale. And they're also, they are kind of stateful, but they don't see deeply into the application, right? So it's really hard to reach certain compliance and governance levels just using bare bones NSG. So customers inevitably bring in the security systems that they need to achieve compliance into the cloud, such as their next generation firewalls, et cetera. And they use those for microsegmentation, which then creates a domino effect where all of these routes have to be constantly added and maintained to make sure that you hairpin or force traffic into the firewall. But then it causes another unexpected or unanticipated thing that most folks don't think through, which is that you end up using your firewalls as core routers in the cloud.
Yep.
Because the firewall becomes the junction of all your VPCs and VNets. And firewalls are not great routers.
No.
They're not. And so what ends up happening is you run into cost problems, you run into scale problems, and you run into these terrible outages. The routing stacks of firewalls can quickly become overwhelmed with the complexity that they have to do in these functions, and they're not always stable. And when you hang everything off this one architecture and that central piece fails, the blast radius is immense. So at Aviatrix, we looked at this scenario and we said there's got to be a better way. And the better way is to do what application developers have been doing in the cloud for years, which is to distribute, to build thin and wide, and to make things agile, right? So what was lacking was the cloud native automation and the orchestration to tell the firewall where to be and what to think for any particular workload or VNet. Thus, you escape this brittle architecture that's so challenging for most people. And then you begin to approach true microsegmentation. You're enforcing policy in that VPC right next to the application or line of business that needs it, but you're not enforcing it somewhere else. And of course, our system, if it sees that this enforcement needs to be done in the subnet, in the VNet or VPC, what it does is it actually orchestrates implicitly for you the security group or network security group. So if it's leaving the VNet, then we'll get it in our firewall and inspect it there. If it's not, we're going to use the cloud native objects to do that. That was another revelation we had.
And Woody just reminded me of some of the knock-on effects or knock-on benefits, really, of this sort of distributed approach in the real world, right? I mean, the reality is when we saw customers take the approach of centralizing this through next-gen firewalls in sort of a hub and spoke traditional model. You always have to remember that anytime you take a hop in the cloud, it costs money. Whether you're passing the traffic or you're dropping the traffic, the fabric does not care. It's going to charge you for every bit in and every bit out. And so by going through by being able to implement this policy in a distributed way, there's actually some pretty substantial knock-on benefits when you're able to drop or allow this traffic, keeping it clean across a hop. If you're able to drop it before it incurs that cost, then there's a ton of really, really great benefits and cost optimizations. The second piece is that a lot of customers would come to us and say, "Hey, we're going to do microsegmentation," and we would say, "Great, we have a great solution for you. What are your policies?" And you would get crickets. They know they need these things, but when you have to actually sit down and define what talks to what, that's a really, really hard thing to do. And so when you're able to start to distribute some of this enforcement in a distributed way, you can sort of enable learning modes you can start to just take a look at your data plane and see what's talking to what, so that you don't have to flip this on like a light switch. You can look at individual environments, look at common flows, and start to build policy sets over time. We have some learning capabilities built into our platform, but I think that's been one of the great things that we've seen, customers sort of mature to, is that, and really just an understanding that this is a really, really hard thing for enterprises to deploy in the real world. It takes time. It can be very error prone. And so any method that can allow customers to do this, in an incremental way, is hugely beneficial to the organization.
That's pretty interesting to me. So instead of looking at net flow information on a Cisco switch or VPC flow logs or sticking a sniffer somewhere and trying to figure out what traffic is going where, you're saying you actually have it in the system where they can actually learn and you can get some good information.
So essentially, Aviatrix becomes the data plane. And so we're routing all of the traffic anyway. And so by nature, we can take a look at what is talking to what across the environment. And then as you sort of decide where you want to insert some of the enforcement, it's the old IDS, IPS that we used to have, inside of firewalls, right? I want to just watch things and let me know what you would do before I actually turn the flag on and say you can go do it. It's the same process here, that we're just taking a look at the traffic that's traversing the network, building out relational maps of what's talking to what, and then that can help guide some of the policy creation.
But one key aspect I believe in, correct me if I'm wrong, with your guys' platform is that because you continually have the application visibility, you can continually monitor applications for any, let's just call it a weirdness. I guess that would be a good technical term to use. So you guys are still, even if it was inadvertently, building on the idea that just because you are in the system at once, you're still going to have to identify yourself eventually if you're allowed to do this access, and over time continually provide credentials and be monitored to be approved based on a policy that carries across that payload or workload, whatever it might be that you're running at that time. Is that correct?
Yes, to a degree. So that then gets us into a conversation of where you want your policy. And I know at some point we're going to have a conversation about SASE, and I think that's a great opportunity to explore that further. Since we're a core networking firewall, and I use the term core liberally because there is no core in cloud, but we're a network security product. The kinds of application visibility and policy that we're interested in is mostly threats. So we're using Suricata and Proofpoint, both fantastic products, both widely in use by the cloud providers themselves, to identify malicious traffic and to, of course, alert and alarm on it. And even if you want to, unlike some other platforms, we can actually proactively shunt the flow, not just quarantine, not just quarantine the whole virtual machine or whole subnet kit and caboodle, which is very invasive, but to know that exact flow, which is poisonous, and shunt it and say, you're off the network. In addition to that, we decrypt and encrypt, so we are a proxy. This is for egress, so outbound to internet, outbound to corp. And through that decryption, we can look at the application stream and the URLs and the FQDNs and make intelligent decisions about who's talking to who should be or who shouldn't be. So that's your typical URL and an FQDN visibility there. When it comes to identity and user and context, that's where we integrate with a larger universe of SASE that's really optimized for that kind of stuff. Because in my mind, as an architect, you want that on your edge.
Fantastic. So you're taking the layered approach to security that, generally speaking, we as enterprise architects recommend to customers anyway to take.
Exactly.
Fantastic.
And I actually like that, and we'll end on that. Being able to take layered security and mix it with zero trust is really what we need to do. To me, it's not an either or, it's a combination of both. I'd like to thank you so much for sharing your experiences and your solution to deal with microsegmentation in the cloud. Great solution. It covers a lot of our security bases, and it seems to make things simpler. So if we can get better, faster, and simpler all at the same time, it's always a win when it comes to technology. Thank you so much. And I look forward to speaking with you on other topics about cloud networking. And I love cloud networking.
Thank you both.
Thank you.